Application developers these days are dealing with mountains of complexity. They have to learn new programming languages and new techniques all the time in order to keep up to date. Once they've built their application, they then need to go ahead and put it in production. And it is often at this stage that the real trouble begins. We've now reached a point as an industry that the infrastructure running in production is often more complex than the application code running on top. So what is a developer to do in this situation? Well, many of them will use frameworks like Ansible and Puppet and Chef to script the rollout and deployment of that infrastructure at the beginning. Once everything is set up correctly, they can go ahead and deploy their application code on top. Unfortunately for a developer, that infrastructure, however, is not static. It will actually change over time. For example, with firmware updates or API changes. The developer can then find themselves in a situation where their deployment scripts, which used to work before, are now no longer working. This is a situation often called code rot, where something starts to degrade over time. The reason why this can occur with such scripting automation frameworks is because there's not much abstraction between the automation code and the infrastructure that's being automated. Put simply, those two things are very tightly coupled. Another situation that can impact on our developer is they find themselves operating in hero mode. So they're hopping from one part of the infrastructure to another, setting things up, configuring things just the way they want. Once everything is ready to go, they can then go ahead and deploy the application on top. Now, the problem with this kind of hero-driven process, if you can even call it a process, is that it depends on the hero. If the hero is available, there's no problem. But if the hero is not available and the wider team doesn't understand the configurations that have been put in place, you can imagine very quickly how problems can start to arise. So what can we learn from these situations and how can we make life better for our developer? This is exactly the challenge that we set ourselves inside the engineering department in UbiCube. We wanted to free the developer to focus on their day job, which is building cool UX for their end users. And how we done this was we decided we wanted to build a cool DX or developer experience that would enable the developer to be freed up from the day-to-day concerns of infrastructure management. So if we take an example like on this diagram where we've got a mixture of infrastructure that might be public cloud, private on-premise cloud, physical hardware, you name it, it's a mess. So how do we manage all that? The first thing that we decided to do was wrap that in a single integration layer. This integration layer forms the first part of what we call our integrated automation platform. The purpose here is to provide a developer with a single REST API to manage all of the infrastructure, regardless of the protocols or the vendors underneath. So put simply, one integration layer to manage everything. Once everything is integrated together, we then want to apply automations on top. So this forms the second part of the integrated automation platform. This enables our developer to take those processes from before, when we were operating in hero mode, and make them automated processes that can be executed on the portal UI via a single button click, which would of course enable the rest of the team to execute those processes with a high degree of ease of use. This integrated automation platform has the additional benefit of protecting the user from changes in the infrastructure at the lower layers. So put simply, we now have that buffer between the automation code managing the infrastructure and the infrastructure itself.